Today's problem is intersection of sorted arrays. This is part of the 12-week interview preparation kit on interview bits. So pause the video, go over there, try the problem, and then come back and we'll walk through it. All right, the difficulty of this problem is easy. It is asked at Facebook and Google. So can't be that easy. It actually is pretty easy. This is a very common problem. You've probably seen it. Find the intersection of two sorted arrays. Or, in other words, given two sorted arrays, find all the elements which occur in both arrays. For the purpose of this problem, as also conveyed by the sample case, assume that elements that appear more than once in both arrays should be included multiple times in the final output. Okay. That's interesting. Let me think about that for a second. Okay. Let's see. So there's an example. We'll walk through one of the examples there to kind of illustrate the algorithm. Now this, you can't see the whole method signature here. Let's fix that and then we'll move it back a little bit. But intersect is taking two input lists, A and B. Do not modify the list. We can't modify the list. It's labeled as final. So we have two integer lists coming in here. Right? That back over a little bit. Can we see the rest of it? Yes. All right. So they do call out that the arrays are sorted. Right there and right here, bolded. They're sorted. Okay. Now, it occurs to me that one thing you could do is just take one of the arrays and throw it into a set. And then go through the second array and try to put those elements in the set. And everything that you can't put in the set, that's because it's already in the set and it's a duplicate. So, so that's one way to do it. That wouldn't work in this case for the reason that something like this, 1, 2, 3, 3, 4, 5, 6. All right, well, it would work in that case, but let's imagine one of those threes wasn't there. That we just take 1, 2, 3, 4, 5, 6 as the first array, put it in a set, and then we go to the second array. And we try to put a 3 in the set, and we can't because it's already there. And we try to put the next 3 in the set, and we can't because it's already there, and we can't put the 5 because that's already there. So what is the result? 3, 3, 5? That would be wrong in that case. The reason that the 3 is in there twice is because it's in the second array twice and it's in the first array twice. The second example, 3 is in the first array twice, but it's only in the second array once. So that only counts as one duplicate. And I wouldn't do it as a set anyway if the problem was presented like this with an emphasis on the arrays being sorted. If you get a question in an interview, probably every piece of information that you get will be important. So if you have a solution that doesn't account for all of the information that you've been given, for example, that the input lists are sorted, you may need to rethink your approach. Now, you might say, well, maybe they just gave me that as a red herring to throw me off the scent. I mean, yeah, that's possible, but it's much more likely that they gave you that information because it's important in solving the problem. All right, let's look at the algorithm here. Let me get a pen. All right. We're going to create a new list called result. We're going to create variables, index A, index B, both initialized to 0. Actually, let me scroll this over here to an example so we can go through it. Example input. Yes. Okay, good. So index A will initially be 0 right here. Index B will also be 0 right here. Now, while index A is within the size is within the range of index of the list A, and index B is still within the range of list B, we're going to keep looping. I may need to scroll that up a little bit more. All right. Okay, so we're going to get val A, val B. Val A is 1, val B is 3. Are they equal? No. Is val A less than val B? Yes. Yes, it is. So in that case, we'll increment index A. Loop again. Val A is still less than val B, so we're going to increment again. All right, this time through, A and B are equal. So we add that to the result. Here's our result list over here. Put a 3 in there and increment both indexes. Loop again. All right, A and B are equal again. Another pair of 3s. So that goes here. Increment both. All right, A is less than B. So we increment A. Now A and B are equal. So we'll put the value in the list, increment both, counters. That's the end of the loop because B is no longer in range. B is too big. Index B is too big. So that's the end. That is our answer. Let's get rid of some of this stuff and run it. Okay. Okay. That is actually a pretty easy problem. It's a common problem. Two sorted arrays, two sorted lists, something like that, and you're comparing them. This is almost always the way it works. Is you just start. It's like a 2-pointer. You start a pointer at the beginning of A, start a pointer at the beginning of B, and based on whether or not they're equal or one is greater or less than the other, you advance the pointers accordingly. Okay. Thanks for watching. If this was helpful, you can hit like, subscribe, check out the playlist on screen to keep ramping up your interview skills. Check the video description and the pinned comment. They both have links to more resources, including a free LeetCode patterns cheat sheet, which would include 2 pointers pattern, like this problem. You can download that immediately. Did I say it was free? Yeah, you can download that immediately, as well as there's a link to Code and Conquer, which is my complete coding interview prep course. And we'll see you next time.